Hello, my name is Lauren Denawi, and today I'm going to be walking you through the UML modeling portion of my Split Smart Expense Tracker system. And this is a software project I developed for my CIS 285 class. The purpose of this system is to make tracking shared expense easier for groups like coworkers and for companies, even personal use. And what I'll be focusing on this presentations are the diagrams that describe the structure and behavior of the system, specifically the class diagram, state diagrams, and sequence diagram. Now, these diagrams help us understand not only what the system contains, but also how the system behaves over time, and how the different objects interact with each other. And hopefully by the end of this presentation, you will have the full picture and how my Split Smart works and what goes behind the scenes and just step-by-step instructions of how it works. Here is the agenda for my presentation. I will start with the class diagram, which will show the core structure of the system, all the main classes, their attributes, and the relationship between them. Next, I will cover the 3 state diagrams, and each diagram will show how one object moves through different states depending on the actions taken by the user or by the system. And then after that, I will move on to sequence diagrams, and that will show step by step how objects communicate with each other during key use case scenarios. And these diagrams really help visualize the dynamic flow of the system. And then throughout the presentation, I will also be connecting each diagram back to the system requirements and the use case flows to explain why each method and each state is necessary and how they build on top of one another. So this is my class diagram screenshot. And this class diagram is truly one of the most important UML diagrams because it defines the actual building blocks of the system. This diagram shows all the classes that make up in the Split Smart application. It includes 3 main categories, and they are the GUI classes, manager classes, and entity, or as known, database classes, and I will be going over them in this presentation as well. The diagram will show associations between classes, such as which classes depend on others and what the direction the information flows. And this will give a visual understanding on how different parts of the system communicate. And when I was designing this, I referenced the system requirements carefully, like features logging in, creating expenses, calculating shared amounts, and tracking payments. And all of them are represented somewhere in this diagram. If you zoom in on the classes, you'll see what I'm talking about. So for class diagram, to identify which classes belong in the class diagram, as I said in the previous presentation, I went through the requirements and I highlighted the nouns that represent real pieces of the data and the system behaviors. For example, the requirements that user must be able to create groups meant that I needed a group class, which I created in my structure. The requirements that they must track expense meant that I need an expense class, which I also included. And because the app allows users to settle balances using payments, that means I needed a payment class as well. Also, I looked at system behavior to determine which classes needed methods, which I also included in my diagram. And here is an example. Because the system needs to calculate balances, I created methods in the expense manager class related to updating balances. The class diagram gives the system structure, like I said before, and it's like it's almost like the skeleton of the project, and everything relies on this UML, this class diagram. Yeah. So next I will be explaining the GUI classes in detail, of course. Let's start with the expense tracker GUI. Now, this is the core of the user interface, and this is where users can view their groups, create new expenses, record payments, and basically perform all major actions. Now, the GUI never performs calculations or data updates. Instead, it sends these actions to the appropriate manager class. And the separation keeps the code organized and much easier to maintain. Next, I will be talking about login panel, and what that does is it handles the login interaction. Now, this is where the user enters their credentials, like their their login and stuff, and it doesn't make decisions at all. It simply just collects the user input and it passes that information to user manager, which is one of the classes. And that basically just handles authentication. And this method really keeps responsibilities separate, and it helps maintain a good software design. Now the manager classes. So the manager classes contains all the application logic. I have user manager, expense manager, and group manager. Now I will go in detail of what they do. Now the user manager is responsible for processing login actions. It also helps you search for groups, and it updates like user details, and it works closely with login panel and other GUI components. As for expense manager, now this one is the most complex of all the manager classes. It handles creating new expenses, editing existing ones, and it will calculate how much each user owes, and then after that it will update balances and expense or payments, and recording payment transactions as well. The class diagram shows all these methods in my screenshot that I uploaded in the previous slide. And last but not least, the group manager, and what that does is it handles everything related to the group creation and membership. This includes validating group names, saving groups to the system, inviting members, updating their membership status. By separating these responsibilities into the group manager class, it avoids cluttering the GUI logic. Now, with manager classes, they're kind of like the brain of the system. They make decisions, they enforce rules, and they coordinate the objects. And that will give you a clean style in the program. Now we're going to be talking about entity classes, and this is where the actual data is stored. I have 5 entity classes in my diagram, which are user, group, expense share, expense, and payment. Let's start with user first. So the user class stores personal information such as the username, email, and password. And as for the group class, that stores group ID, name, and member list, and is also responsible for supporting invitation, acceptance, rejection, and when the members leave. Then we're going to be talking about expense class. So that one, it stores the main detail of expense, like the amount, date, description, and if the user wants to upload a receipt, they can. It's optional, it's not required. As for expense share, now this one is the important class. It stores the split amount for each user involved in an expense. For example, if let's see, if 4 people went out to dinner and they wanted to share the expenses, each part of their share would be recorded separately within this class. As for payments, so the payment class stores the amount one user pays another. Now this helps updating the balance owed between the users. And the beauty of it is together the entity classes represent all the real data in the system, which is pretty important within the program. So this is going to be the last slide for class diagrams, and I'm going to be talking about how the class diagram connects to the use case. I think it's important to show that the class diagram didn't come out of nowhere. It is directly connected to the use case that I built on Enterprise Architect. And an example of it would be create an expense, and that's a use case, and it produces the method create expense and recalculate balances. Another example I'll throw in there is the record payment, and it also produces methods like create payment and update balances. Now, everything in this class diagram must exist for a reason, obviously, and the use cases give it those reasons. They describe what the system must do, and the class diagram also shows how the system supports those behaviors. Now, for our next topic in this presentation, I will be talking about state diagrams. I created 3 state diagrams because the system has several objects and that the changes states over time. Now, each diagram focuses on one particular object. The member state diagram that I will show in the next slide is how a user's membership changes after being invited to a group. Next would be the group life cycle diagram, and what that does is it shows how a group goes from created, active, archived to deleted. And then my final state diagram would be the search diagram, and that will show how the system behaves when the user performs searches. And each state transition is triggered by a method that already exists in the class diagrams, the ones that we talked about earlier within the previous slides. And all the diagrams are consistent as well. So for my first state diagram, I'm going to be talking about the member state diagram. This state diagram starts with the invited state, and then once the user receives an invitation from a group admin, they are placed in the state. If the user accepts the invitation, they move to the active state, and this represents full membership in the group. As for the active state, 2 things can happen. The user may voluntarily leave, which will move them to the left state, or the admin will remove them, which moves them to the removed state. There's also a rejected state for users who don't want to join the group. And what this diagram shows is how user membership evolves over time. State attribute connections. These states transition directly corresponds to the group member attribute in the group class. When a user accepts an invitation, the system adds their ID to the members list, and when they leave or are removed by the user or the group admin, the system removes their ID from the list. This is exactly why the class diagram and the state diagram must match. The state changes must represent real updates to the system data. Now we're going to be taking a look at the state diagram, my second one, which is the group state, and that's like the group life cycle. A group is first placed in the created state when the user submits the group's detail. Once the group is ready to be used, like an example of this would be when the members start joining, it moves to the active state. If the group is no longer needed, but the admin doesn't want to delete it yet, they can archive it and it will store, and this will move the group to the archive state. Finally, the group can be permanently deleted, which moves it to the deleted state. Now, these transitions match the methods create group, active group, archive group, and deleted group. Just like before, each state transition corresponds to the real updates in the group class. We have the created group method, which sets the initial status, the active group method, which changes it to active, the archive group method marks it as archived, and the deleted group marks it as deleted. The state diagram will ensure the system manages groups consistently throughout usage. This is going to be the last slide for my state diagram, which is the user search. Now, this state diagram will show the search process. First, the user starts by entering search criteria, and then when they submit, the system moves to the searching state. If the results are found, the system moves to display results, and if the results are not found, it moves to no result found. Now, with this user search diagram, it truly helps visualize what is otherwise a quick behind the scenes process in the system of when you search, because typically when you do this, you don't really think much of it, but when you actually look at the behind the scenes, you could see the traversal through it. My next topic will be sequence diagram, and it will be the last topic of this presentation as well. Sequence diagrams will show how objects interact over time to complete a task. Every message in a sequence diagram should match an operation in the class diagram, and it will show consistency throughout the presentation as well, which is very important within this program and this diagram as well. My first sequence diagram is create expense. In this sequence diagram, the user begins by opening the add expense screen, and they will enter the amount, date, description, and they will select participants, aka users. Then the GUI will pass this information to the expense manager, which creates an expense record. After that, the expense manager contacts user manager to create records that link the user to the expense. And then once that is done, expense share records will show the exact split amount for each user. After all that, the system recalculates balances and updates the amount owed. The GUI displays confirmation that the expense was created, and this diagram helps visualize the complete life cycle of an expense being added and the split between the expense and how it connects to the user as well. This will be my last and final sequence diagram and presentation before the conclusion slide, of course. And this sequence diagram is called record payment. So let's start off with the user. So the user enters the payment details through the GUI. The GUI sends the detail to Expense Manager, which validates the information. If the payment is valid, then the system creates a payment object. Expense Manager will then update the balance between the payer and the payee. After that, then will be expense share, and it's not guaranteed all the time that expense share will be involved, but since it tracks balance details, it might. Finally, the user will receive the confirmation that the payment was recorded, and this will help keep all balances accurate and up to date. To conclude the class diagram defines the structure of the system. The state diagram shows how objects change over time, and the sequence diagrams show how those objects interact during real scenarios. By connecting all these diagrams back to the requirements and the use cases, this ensures the system is consistent, complete, and ready for implementation. Thank you so much for watching my presentation. Again, this is your speaker, Lauren Denawi, and I truly hope you enjoyed it and were able to understand my diagram consistently. Thank you so much.